Okay, so we're doing problem 15 on homework 1, and it says a spherical wave with a wavelength of 2 meters is emitted from the origin. At one instant of time, the phase at r equals 4 meters is pi radians. At that instant, what is the phase at r equals 3.5 meters and at 4.5 meters? So our givens are that our wavelength is 2 meters, the phase, which we can call phase 1, at r equals 4 meters is pi radians. So it's asking us to find another phase at r equals 3.5 meters and then at r equals 4.5 meters. So it's saying that it's at the same instant of time and it's just the different positions we're looking at. So it's just asking us for like the change in phase between these two. So then our formula we can use is change in phase equals 2 pi delta x over lambda. And then because this is a spherical wave and it's not in one dimension, then our x is going to be the radius instead of the x value. So just kind of expanding all of this, will be our difference in our phases equals 2 pi, and then the difference in our radii over lambda. So we're going to kind of just solve for the second one, this one twice, just using each of these values they gave us. So this will be our first r, and these are both our second r, so we're just going to use one of these at a time. So we'll just rearrange this to solve for our second phase. And then in the problem, it told us that the phase for this is pi radians for phase 1. And then we can just choose our first radius to be 3.5. And then they gave us the first this radius R1 as 4 meters. And so this comes out to pi minus pi over 2, which is just pi over 2 radians. And then we'll do the same thing for this R2 value. So we can just take this that we've already done and just plug in a different number. So then our phase 1 is still pi. And now for our R2, we're going to use the second one. Which comes out to pi plus pi 2. And that equals 3 pi radians. And so these correspond to the phases at these different radii of the spherical wave.